Right, question 5, and I'll do question 6 in this clip as well. Getting a little harder now, higher level stuff. So you've got a child of a certain mass on the swing, pulled to one side, and you've got a diagram there with all the forces on there. What is the net force on the seat? So you've got to think about this, what's actually being exerted on the seat. Right, now before you think too hard, there's a key word here in this blurb, and it says that in equilibrium. What does that mean? If something's in equilibrium, what can you say about all the forces, the resultant forces? Once you've got that sussed, the next two bits aren't too difficult. You've got to do a triangle of forces, so you should be able to turn this into a nice vector diagram. Think, what to find the total force, you've basically got to add them up. These, then, you're not seeing their size at all, but you know the direction from that picture there. So that might be the tension. That must, and if you add that to the weight must go down, and it's obvious which direction that force is there. So and you know the weight because you know the mass, and don't forget our good friend G, and you know the size of this force there. So if I just clear some of these lines here so you can see it a bit easier there, I just point to a few more things. So you do a vector diagram. The picture gives you the direction of the forces but not the size. The numbers give you the size of a couple of forces, and you should be able to find everything from there. And for the angle, you just do a bit of trigonometry. Okay, we'll move on to question 6. Question 6, you've got a gardener pulling a heavy roller, and you're given quite a bit of information there. Make sure you're aware of all the information. Dive into the question, find out what they want you to do, and then read the information again. Works for some people, so try that, might suit you well. But calculate the horizontal component of the force of 300 newtons. So once again, you look at the diagram. This force, you've got the size of it. The picture tells you the direction. It doesn't. This line here, though, doesn't represent the size. It just shows you the direction. That happens to be the handle, but you've got to draw a vector diagram. So do one yourself. That's that. You know what the angle is here. You're told it's 30 degrees. I missed the 0 there. So 300 newtons and 30 degrees, and you should be able to find the horizontal component from that, which remember is this way. So the net force in the horizontal direction. Once again, read through the question. The net force. Is there anything key that they're telling you there about the net force? Or about anything about the motion? If you look closely, you'll find this phrase here. And if you think about good old Newton and his first or second law, you'll be able to tell me what happens, what are the conditions for something moving with a steady speed or a steady velocity. So hopefully you'll be able to work out what the net force is from that without actually crunching any numbers, and so you determine the magnitude of the resistive forces acting on the roller. And which way are the resistive forces? They're going to be cancelling out whatever the horizontal force is there. Okay, the final bit, the vertical contact force acting on the roller. Well, once again, you've got to think about, is it moving in the vertical direction? Okay, it doesn't tell you anything about any vertical movement there. We know that there's going to be the force due to gravity pulling down, and you can work that out. And if it's not moving up or down, there must be another force interacting with that one. And that's all I'm going to tell you. You can work the rest out yourselves.